Hello everyone, this is Andy and I'm glad that you are here to learn patterns and algorithms and master Leetcode style questions in JavaScript. We have about 20 high quality patterns that we'll be looking at during the course of 40 plus upcoming videos that I've planned for you guys. So if you're anyone who is a beginner or a nuanced JavaScript developer and want to master Leetcode style questions to pass interviews, not just for FAANG companies, but for any company looking to hire engineers with solid algorithmic background, I believe this is all you need to learn and how to use JavaScript to your advantage. Have a solid plan and conquer any Leetcode style question with confidence. I'll be starting off with simple pattern-based videos, and at some point we'll create a list with all the questions that we will be looking at and the main patterns that I think are worth learning. There are so many resources out there, but I am here to go over some high quality patterns that I think will help you understand how we can use JavaScript to our advantage to solve questions and be confident in algorithmic based interviews. So with today's video, let's start out with binary search. And this would be one of the very basic, fundamental, important patterns that we should at least go through once. And there will be 6 questions that we'll be covering. And I hope by the end of the 6th video, we'll be able to master binary search and we'll be able to use this technique in all the other questions that may pop up in the interviews, right? So to give you a brief introduction about binary search is an efficient algorithm that primarily works on arrays or list data structure. It kind of works by narrowing down the search range by half each time. Binary search, from the name, we know that we are trying to search for an element from a list or an array. And if you have looked up a word in a physical dictionary before, then you would have already understood a little bit of binary search in real life, because every time you look into a dictionary, you seek to find the word that starts with the letter you're looking for, and then you go either to the left of it or to the right of it. So the key observations that we need to make for binary search is that the array should be sorted, and then we pick a random element in the array and compare it to the target. Now that random element could either be greater than the target or less than the target. If it happens to be smaller than the target, then we know that our target element falls to the right of this random element that we have picked. If it is greater than the target, then we know that the target lies in the left part of the array. Now we repeat this process until we find the target element. So instead of picking a random element, we always pick the middle element to standardize our process. And so this way we can discard half of the options in our array every time and shrink the search range by half. So a little bit of math exercise here. Let's say we have our array length and we'll call it n here. Could be any arbitrary number, and then we divide it by 2 initially, which means we're trying to find the middle element. Now we try to find the middle element, right? And then we try to find middle element from 0 to n, and then we divide it by 2, which is n over 2. So now our new search space is only n over 2. Now we divide it further by 2 next time, depending on our conditions, and then we get to middle of middle, which is n over 4. And then we keep dividing it until we get to a point where we finally find the target, or if n equals 1. So this little exercise that you'll see here is nothing but dividing the array by 2 until we either get to size 1 or we get our target element. This can be simplified in a sense that the last one, as you can see here, is nothing but array divided by 2 to the power 4, which is 16. Now you are dividing array by 2 to the power 4. So in other way, if I ask you, how many times do you have to divide the array in order to get the target element or get to n equals 1, you would say log n, which is log 16. And in computer science, a simple nugget of knowledge, log whenever is referred to is always log base 2 and never log base 10. So we are always thinking about log with base 2. And so this is a very simple example. And so the time complexity for our search is always going to be log n, where n is the length of the array, because, well, we went through the whole math exercise to understand why it's log n. Each time we are shrinking our search space by 2, and then we are going to do it until we either get our target element or we get to a point where the total length becomes 1. A little implementation for you guys here. Binary search is a method that we implemented here. We take array, target, and then we start from the left and to the right, and then left is less than right. We loop through, we have a while loop here which runs from left until it's less than equal to right. In each iteration we try to find the middle element in hopes to shrink our array's size by 2. And then there's a very interesting piece of code right here. Let's discuss this a bit. So the left plus, we could simply either do left plus right over 2, or we could do this whole thing that I've done here. Now, there's a reason why we can't use left plus right over 2. And the reason is pretty simple. I've tried to elaborate it here, is that left plus right could potentially lead to overflow. Right? And so the length of the array could be huge already in 10 to the power 22s. And then if you try to add the left pointer and the right pointer numerical values, you would end up with a number which is far greater than the limit, integer limit, that's allowed, at least for your compiler. Or if you're using Node.js, then it would depend on the amount of memory that the operating system has allowed your Node.js process to use. And so in order to avoid any kind of overflows, we usually go with right minus left over 2. And so in this case, a simple thing that could be done is right minus left over 2. But since right minus left over 2 is going to give us a decimal value, we use math.trunc function in JavaScript to get the integer part of the result. Now, once we get the integer part, we still have some work left to do. And that is, right minus left is going to yield us an element left of our current middle index. So we want to get back to our left. And so we add left to the number. And eventually we get to our middle element. And then the 3 straightforward conditions, which would be to check if the middle index indeed holds the target element that we are looking for. If not, we're going to check if target element is greater than our middle element. If it is, then we're going to shrink our search space by incrementing our left pointer and disregarding anything that falls to the left of the left pointer. If that's not the case, then we know that our target is less than array mid. And in that case, we're just gonna decrement right and update it to mid minus 1, meaning we are disregarding anything that is to the right of the middle element. And we keep doing that until we hit our exit condition, which is left is less than equal to right. And if we don't find it, then we just return -1. Now, how would you do it in an interview setting, right? In an interview setting, they would just give you a simple method and they would ask you to implement binary search. The 2 places where the interviewer will try to assess your skills are, number 1, whether you are able to identify the exit condition. Number 2, whether you are really concerned about the nitty-gritties of integers, overflow errors, exceptions in your code. And if you are able to demonstrate that you are really careful with your code and you understand the bounds of integers, then it would be really impressive, and the interviewer may even ask you to just walk through an example after that. And so in an interview, once you're done writing the code, you will have some time to walk through a couple of examples. Let's see how we can do that in a real interview. Let's say once you're done writing the code, the interviewer asks you to walk through an example, because, well, we don't have a way to run the code. And so what we do here is we start out with some comments. We pick a random list of integers, and then we know that that will be in a sorted order because that's a prerequisite for a function. Next, we say, okay, I have my left pointer set to 0, right pointer set to the very end of the element, which is array length -1. And then I'll run through my code by passing this array. So in the very first iteration, I'll try to find the middle element. And I know the middle element is going to be somewhere here. And so the array is divided into 2 segments. So this is the first iteration. Now, once the array has been divided into 2 segments, I would want to find the target element. In this case, let's say our target element is 8. Now, if the target is 8, then we need to find, we need to check the conditions that we have already established here. This is the middle element. Is the middle element less than 8? It is. So then we disregard this whole portion, and then we update our left to mid +1. And then we go ahead and let the right pointer be where it was at before. And then we follow the same process. We try to find the middle element. Again, we're going to get the middle element here. So this is going to be second iteration where it has divided the remaining array into 2 equal parts. And now, since 9 was the middle element, is 9 less than the target or greater than? It is greater than the target. And so we disregard this portion and instead update our right to say mid -1. 9 was mid -1 is going to be 8. Now in the next iteration, we are again going to find the middle element of this array that we have. Now the middle element of this array is going to be 8. And luckily, the 8 is already the target that we are looking for. And then we return 8. So this is a very simple example of how you can walk through an example use case in your during your interviews. Always remember to also include an example for edge cases. For example, if the target is, let's say, some arbitrary number 7, but then your input is just an empty array, then you need -1. However, does your code handle that? Well, it will, because the loop will never start, because the left is never going to be less than, in the very first iteration, the left is going to increase and it's going to be greater than right. And so you're going to end up with -1 at the very end. Similarly, you can go with a very huge input array as well, but it's not ideal for interview cases. So this was about binary search. Again, to iterate, the space complexity here is O of 1 because we are not using any other data structure to store the values. The time complexity is big O of log n, where n is the length of the array. Log n here means the number of times we divide the array in half. So that was it. That was all about binary search, and we're going to look into how we can utilize this method to our advantage to solve more complex problems. There's one small piece that I want you to take away today, and that is binary search is usually considered as something primitive, and then that we can only use it when we have a list of things that are in sorted order. But interestingly, binary search works beyond sorted arrays. You can use binary search whenever you can make a binary decision to shrink the search range. We'll see this in the following questions in the following videos. Until then, keep practicing Leetcode, keep practicing JavaScript. If you want to learn more about JavaScript, I would recommend clicking on the links in the video description below. Thank you so much for watching this. Have a great day ahead. Bye-bye.